Hello, and welcome to our program, Astronomy for Everyone. Our special guest this month is Dr. Karen Bjorkman from the University of Toledo. Dr. Bjorkman, welcome to our program.
Thank you very much, Don. I'm happy to be here.
Well, thank you. We're going to be covering several interesting topics about Dr. Bjorkman's work both at the University of Toledo and elsewhere. If we could start out, Dr. Bjorkman, what's your current position at the University of Toledo?
I am a distinguished university professor of astronomy, and I'm also at the moment the dean of the College of Natural Sciences and Mathematics, which is where the astronomy group is located, in fact.
Oh, I see. So that probably keeps you quite busy.
It does, yes.
All right. I always like to ask our special guests who are in areas such as yourself, what inspired you to choose a career in astronomy?
Well, you know, that's really a good question for this particular week. My inspiration for wanting to study astronomy was really the moon race and the Apollo program and the whole idea of people going out and walking on another planetary surface. I was a kid at the time, and we actually lived in Florida, and we could actually watch the launches from our front yard. And so we would go out, we would watch them lift off on television, and then we would run outside to watch the Saturn V lift off. And I remember wondering when they went to the moon, you know, what was it like there, and how did they get there? And I wondered what it was like to walk around on the moon, and I wanted to know more. And that really kind of got me interested in the whole concept of space and astronomy and what was out there and what was it like.
And then you followed up on that by taking the necessary science and math courses.
Right. So I actually majored in physics as an undergraduate, which is a good major if you want to go into this area, at the University of North Carolina in Chapel Hill. And then I actually worked for a couple of years after that for an aerospace company, and then went back to graduate school at the University of Colorado for my master's and PhD there. And that's how I kind of got here. Then I worked for a while, as we'll talk in a minute, about at the University of Wisconsin on a space shuttle mission, a telescope there, and then ended up in Toledo.
Great. It sounds like an interesting pathway. Back in those days, I don't want to date it too far back, but as a woman, did you find you had to give some extra push?
Sure.
To try to get into this field?
Absolutely. It was a matter of being persistent and not listening to the naysayers. My parents were extremely supportive, which really helped a lot. But I will tell you that, you know, in all honesty, I had a physics teacher in high school who told me girls couldn't do physics. And I kind of found that to be a challenge. And I decided, oh yeah, I'll show you. So
great.
Maybe I did.
Yes, I think you did from where you are today. That's great to see more women in areas that used to be, oh, that's just for the boys.
Yes.
We used to hear back then. Now, with what you're doing now, going back, you alluded to it a minute ago, what are some of the projects that you've worked on in the past that our viewers might be interested to hear? Well,
I've worked on a number of different projects, but the one that might be most interesting to your viewers is actually a project to do astronomy from the space shuttle. When I was at the University of Wisconsin, I went there to work on a project called the Wisconsin Ultraviolet Photopolarimeter Experiment. That's a mouthful. We just called it Whoopee, and we thought that was a good name.
Yes.
We like to say Whoopee is not just an instrument, it's an attitude. And in the picture you're seeing right now is actually the payload on the space shuttle with the Astronomy Observatory, so-called. And there were 3 telescopes aboard that, one of which was Whoopee. One was a telescope built at Johns Hopkins Institute, and the third one was built at Goddard Space Flight Center at NASA. And we flew the first mission in 1990. The 3 telescopes were on a pointing system, so they all pointed at the same thing at the same time, but they were all designed to measure different things. And our telescope was designed to measure the polarization of light, which is sort of the direction that light is oscillating. And it turns out that that's a very useful thing to measure because you can learn about things that you can't even see. My interest is in disks around stars, and so it turns out that most of these stars that we're looking at are so far away that you can't actually see the disk. But one way you can find out that it's there is by measuring the how it polarizes the light that comes from the stars. It bounces off of atoms in the disk of material around the star and changes that direction of oscillation, and we can measure that. So we were able to use that and for the first time make those measurements in the ultraviolet, which is, of course, light that doesn't mostly get to the Earth. We have to go into space to observe that.
Exactly,
Yeah.
exactly. So that sounds like it was a very exciting time to be in astronomy.
It was. Well, in fact, I thought originally when I took the job it would just be for a few years, and I ended up staying in Madison for 7 years because we flew it twice. We got to fly the payload again in 1995, and so I got to work with training the crew on how to use our telescopes. We spent a lot of time at Johnson Space Flight Center and Marshall Space Flight Center and Kennedy Space Flight Center, and so I got to know a lot of those places pretty well. So.
Very, very exciting.
Yep.
Wow.
Well, I'll just comment, one of the fun things is that in astronomy, whenever you look at objects in a new way that hasn't been done before, you always learn new things. And it's the most fun and exciting experience to get data down, and for the first time, you know something that you know nobody else knows. And for that tiny instant of time before you go running around sharing it with everybody, you're the only one in the universe, as far as you know, that knows about that, which is kind of fun.
It is, because prior to that, we don't know what we don't know.
Exactly.
And so you get those aha moments to enjoy.
That's correct. Yep.
Anything else about that project, or was there another one that...
Well, I'll mention one thing that's interesting about trying to do astronomy from the space shuttle. Of course, the space shuttle has astronauts aboard it, and they're moving. And you get to learn a lot about how Newton's laws work when they bounce off of the walls, or we had 2 crews. They were working 24 hours, so we were working 24 hours on the ground as well. And they would get up and fix breakfast, and they'd be moving around, and we'd see the star it's when you have your small telescope out there and somebody kicks it,
Yep.
or somebody stomps by and your star image shimmers.
Sure.
That happened to us whenever they got up. And on the
my.
first mission, they have to exercise, of course.
Yes, yes.
And so they were using a treadmill. Well, you can imagine what that did to our star
The
images.
vibration
Yes.
must have been, oh
so
my
on the
goodness.
second mission, we convinced them to take a bike instead of a treadmill.
Bill?
Yeah,
Okay.
so.
Interesting, interesting. That's... And how has that knowledge progressed to today, with taking the knowledge that you
Right.
learned from this project forward? Is there?
Well, so we learned a lot of things that we didn't expect to find, and so that has sort of changed how we investigate the disks around these stars, and we're using some of the similar techniques now from the ground to do some of these studies.
Interesting. Again, having to do it from space in ultraviolet, because
Right.
fortunately our atmosphere protects us
Yes.
from a lot of that.
Exactly.
Is there a distance that beyond which you can't do that with a star? Even?
It turns out we can actually measure the polarization from quasars. So we can go very far with this. If
yes.
we can get an observation, a picture, or a spectrum of it, we can use a polarizer. It's the same kind of thing that's in your polarized sunglasses, and we just turn it different ways, and we can measure the polarization of the light, even from quasars.
Wow. And
Yeah.
those are quite distant.
Exactly,
Yes, as we know. And so it's very exciting to be a part of that, especially with the shuttle, which
Yes, right.
Was also an exciting time working with, I suppose there was governmental agencies that...
Sure, we were involved with NASA very heavily, of course, and working at their facilities. During the mission, we were actually at the Payload Operations Control Center in Huntsville. And so that's where we were controlling things from and talking to the crew all during the mission. So
Great.
it was a wonderful experience, and it's not something I would ever trade because it was just exciting.
Sounds very exciting indeed. We're going to take a short break at this point to bring you a term of the month. If you have a question, you can send us an email. The email address is down there at the bottom of the screen. If you have a question about what we've been talking about with Dr. Bjorkman today, or any other question about astronomy or space science, we'll be glad to answer it. And again, right after this break for Term of the Month with Stephen Whitty, we'll be back with more interesting conversation with Dr. Karen Bjorkman.
The term of the month for August 2014 is special relativity. Now, when Einstein developed special relativity, he had 2 ideas. One is that the laws of physics are the same for all observers. And the second idea is that all observers measure the speed of light as the same speed, the speed of light. Now, the first idea makes sense. Physics works the same for everybody, everywhere. But the second idea, that the speed of light is measured as the same speed for everybody, doesn't really make that much sense. It just happens to be true. So let's take an example, Bob and Alice. Alice is riding on a train. It's a very fast train. And she has a flashlight. And she shines it forward toward where the train is going. And she measures the speed of the light coming out of the flashlight, and she measures it as the speed of light. Bob is on the ground, and he sees Alice whipping by on the train, and he also measures the speed of light from Alice's flashlight, and he measures that as the exact same speed, the speed of light. So, but one expects that Bob should measure the speed of light as the speed of the train plus the speed of light. It should be faster, but it isn't. It's exactly the same. So Einstein came up with a way for this to sort of make sense, which is that there's a translation that Bob has to do in order to figure out, when he measures something, what Alice, who is in a different, who's moving, what she would measure. So we say that measurements are relative. They're relative to something, to different places, and that there are no absolute measurements. But it's not exactly true that, oh, well, since all measurements are relative, that it doesn't matter where you are. It matters exactly where you are, because you can't do the translation from one person to another if you don't know all of the details. Now, GPS, we use GPS for positioning. It turns out that GPS becomes wrong by about 6 miles a day if you don't take into account special relativity. The term of the month for August, special relativity.
Thanks, Stephen, and welcome back to our program. With me here in the studio is Dr. Karen Bjorkman from the University of Toledo. Now, Dr. Bjorkman, before the break, we were talking about some of the projects you've worked on in the past, things you're very proud of course. But can you fill us in on some of the current things that are going on in astronomy at the University of Toledo?
Absolutely, I would love to, because I think there are a lot of really exciting things happening there, and I'm always happy to share them.
Great.
If you look at, I brought some pictures with me to sort of illustrate these. The first slide just sort of shows you a couple of things that are recent that we're very happy about. One is we've recently renovated our planetarium with a full dome, state-of-the-art, high-definition projector, and so we're able to do amazing shows with that now. We're even starting to develop our own planetarium shows working with the art department, and so we're excited about that. And then we also, in the last 2 years, have become a partner with the Lowell Observatory in the Discovery Channel telescope outside of Flagstaff, Arizona.
Oh, yes.
And so there is, you can kind of see a little picture of it there on the bottom right. That telescope is a 4.3 meter telescope in a beautiful dark site in the Coconino National Park. And so we're really excited about that. I've already had several observing runs out there. I've taken a few of my students out there, so and many of our other faculty, staff, and students are also doing research out there using that telescope.
Very interesting.
Yep, it's fun. We do, on the second slide, you'll see a picture of our own on-campus observatory, which is the Ritter Observatory. That's actually on the main campus of the university, and you would think that, of course, we're in Toledo, so we're in the city lights, and however, we have enough instruments there that we can do things even in bright skies. And so we have a number of projects going on. We have a camera, we have a polarimeter, which is a follow-up to what I was talking about earlier. We have spectrographs, and our students are doing research using them. Our faculty are doing research using them. So it's been renovated with some new instruments recently, and there's a lot of fun things going on there. And it's actually open after planetarium shows on the first Friday of every month. You can even get a tour of the observatory if you happen to be down in the Toledo area.
Is it possible for the general public to look through the scope? Is that?
On those open house nights, yes, exactly. So we usually put it on something entertaining and let
Yes.
everybody take a look. It's a 1-meter telescope, so pretty good size.
Yes, it is.
Yeah.
Yes,
Yep.
it is.
Yep. And then actually in the next slide, you can actually see the telescope through the slit. This is one that I just took from the roof of the building next door. Had them turn the lights on so that we could see the telescope in there and kind of get a sense of the flower petals that cover the top when we're not observing. Then the next slide shows us the Discovery Channel telescope, quite a bit bigger. You can see from the scale there of the ladder sitting there. That is a 4.3-meter telescope, and that's the one outside of Flagstaff. And the next slide shows you a little bit of the site where the telescope is located. It's up on a little ridge there in the Coconino National Forest, and you can see a couple pictures of the telescope. I was amused when that's Stephen Levine, who's the telescope, the chief scientist for the telescope.
The fellow in the center.
The
shot
fellow in
that
the
you-
center, and he
Yep.
was actually controlling the telescope with his iPad, which I thought was quite amusing. So it's a
Very.
lot of fun to work out there. The next slide is just a couple of sample images that we took with the first instrument on the Discovery Channel telescope. The LMI, which stands for Large Monolithic Imager, is a big camera basically. And these are just some test images that were done. You can see that they're pretty spectacular.
Yes, they are. The definition in the spiral galaxy is great.
Yes, exactly. And so we're incredibly pleased to be a partner in this project. And there's a lot of exciting science yet to come. It's only been online for about a year now. And so we're really looking forward to what's going to come out of that.
I can see why.
Yep. And of course, you mentioned about other projects. So the next slide, this is a place where I've done a lot of observing. That's the top of the Mauna Kea volcano in Hawaii. And that's a great site for infrared astronomy because it's so high. You're at about 14,000 feet up there. And most of my work has actually been at the IRTF, the NASA Infrared Telescope facility up there. And so we can actually do remote observing from Toledo using that telescope from time to time.
I was going to ask you about remote
Yep.
observing.
Yep. And so it's very different to be out there versus sitting in Toledo at a computer screen. And I'd rather be there, but sometimes you can't be flying back and forth to Hawaii all the time, much as we would like to be.
Yes.
So it is nice to be able to do that remote observing. So, yep. Then the next slide just shows some of our astronomers at Toledo are, of course, working with space-based telescopes, the Hubble Space Telescope, of course.
Yes.
The Spitzer Space Telescope and the Herschel Space Telescope and the Kepler Telescope. Actually, one of our graduates is the project scientist for the Kepler mission, discovering all those exoplanets, which is
Terrific.
really fun. We had
Yes.
him back last year, actually, to give a talk and meet with our students, so that was fun. But we have a wide variety of research going on there because we have astronomers who are interested in all kinds of things from the formation of stars to the end stages of stars, supernovae and galaxy formation. Pretty much across the range of astronomy, we have people who are interested in those different areas. And some theorists as well who are doing modeling, using computer simulations and that sort of thing. In the next slide, you'll see just a few. I just pulled a few pretty pictures because I like them. These are some planetary nebulae. Some of them, I'm sure many of your viewers will recognize.
Indeed.
And these are all nice Hubble pictures of some of these planetary nebulae. We actually have one of our professors, Dr. Witt, who is an expert on that one in the upper middle. It's called the Red Rectangle, and they're doing some very interesting work on studying that funny structure in that one. And then in the next slide, of course, not all stars turn into planetary nebulas. Some of them blow up, and these are supernova remnants, and some of which have been studied by some of our astronomers at UT. And these are, again, Hubble images and also some ground-based images tied in here.
Are these the ground-based just mainly in visible light?
Yeah, they're usually, actually, when you see those colors, it's interesting because they aren't necessarily the real color you would see with your eye. They're usually designed to represent something that you would see. So, for example, the red might represent hydrogen, and the blue might represent oxygen. And so by doing that, you actually can convey even more information than just from the colors alone by looking at the
Because
image.
the colors are assigned.
Exactly.
Aye,
That's
okay.
right. Yep. And then the last image is just the famous closest spiral galaxy to our own, the beautiful Andromeda Galaxy M31, Messier number 31. And I just show that because one of our faculty members, Dr. Rupali Chandar, is very interested in star clusters, and she does what you might call astronomical archaeology. She's looking at, by looking at the star clusters in the galaxies, looking at how they've evolved. So there are a lot of really fun projects going on there. And then the last slide I just brought with me, because this is one of my favorite sayings. It's a quote from Carl Sagan, who said that somewhere, something incredible is waiting to be known. And I think we just have to be there, be reaching out and trying to learn all we can.
That's right.
It's a lot of fun.
Reach for the stars.
Absolutely.
I have to tell you that I was totally unaware that the University of Toledo had such an extensive astronomy program, if I can call it that, the kind of work that is going on out there that I think most people would assume would be going on in places like California or somewhere else around the world.
That's right.
But it's really right here
It is.
in our backyard, really.
And for all you prospective students out there, we offer degrees in astronomy at the undergraduate and graduate level. So you should think about coming visiting.
Yes, take a look. And two Michigan residents do get in-state tuition rates.
Absolutely.
So it's always a good thing there to save a few dollars
That's
and
right.
Get a great education as well. Well, I would really like to thank my guest, Dr. Karen Bjorkman, for being here with us today. You can check our website. The address is down at the bottom of your screen for more information about topics on this show or really any of our other shows. And coming up next with What's Up in the Night Sky is our own Stephen Whitty. Stay tuned.
What's up in the night sky for August 2014? The days are getting a little shorter. They're still quite long in August. Sunrise starts at the month at 6:20 and ends right around 7 a.m. And sunset starts at 8:50 and by the end of the month ends at 8. So the moon phases are on Mondays. The very first quarter is on the 3rd. The full moon is on the 10th, the third quarter is on the 17th, and the new moon is on the 25th. Now, Mars sets at midnight, more or less, but is best at 10 p.m. So it's 10 p.m. is a compromise. It's when Mars is highest in the sky, but an hour after sunset, so the sky is dark enough. And Saturn sets around midnight and is also best at 10 p.m. Now you can see Vesta and also Ceres, well, Ceres would be in the image. They're still in this scene. It's still fairly easy to spot them. They're not right next to each other like they were in July. Uranus rises at 1 a.m. and is best at 5 a.m. That's basically an hour before sunrise. And Neptune is up all night long. It is best probably at midnight. That's when it's highest in the sky. Opposition is on the 26th of August. That's when the Sun, the Earth, and Neptune are all lined up, and Neptune is as close as it gets. Venus rises at 4 a.m. and is best at really about 5:15 a.m. Venus is best earlier in the month. This curved line here is the path of Venus through the sky, and so it's we're losing Venus as the month goes on. At the beginning of the month, watch out for meteors. The Delta Aquariids, which were really kind of a peak in July shower, is a very wide, no real defined peak shower. And in the first week of July, you can still see them. And at that first part of the month, we have the first quarter moon, so after midnight, when the moon sets, is pretty good. The Perseid meteor shower peaks from the 10th to the 13th. These are very fast and bright meteors that often leave meteor trails. But the full moon was on the 10th, so it's going to wash out a lot of the dimmer meteors. So after the full moon on the 10th, we have a waning moon. The moon gets dimmer, so you actually are better off looking for meteors before midnight. But before the 10th, you have that first quarter moon, so you have sunset, moonset. You have moonset, and you have a darker sky in the morning. Don't forget, you may be hot during the day, but you may be cold watching meteors at night. So bring clothes that make you warmer than you can possibly imagine being. And so that's what's up in the night sky for August. But we also have one more thing to talk about. Here is Don again with me to talk about our friend John Schroer.
I want to take a few minutes before we close our show tonight to let you know about our Astronomy For Everyone crew member and friend, John Schroer. John has not been on the show for the last year and a half because of complications with diabetes. And sadly, last July 14th, he lost that battle. He was with friends and family in his hometown in Cincinnati. He will be remembered by all of us here in Detroit, both his colleagues on Astronomy For Everyone and his co-workers at the Detroit Science Center. I had the privilege to work with John there from 2007 until 2011. And his genial smile and hearty laugh will be remembered by all of us in the years ahead. John was the education coordinator in the planetarium at the Detroit Science Center. He was also heavily involved with the planning for the Astronomy at the Beach event at Kensington Metro Park, which was held every year in September. And he was also heavily involved in a number of other public outreach events. We want to remember John. His name will remain in our credits as the creator of both the opening and the closing. And to remember John best, I'll have Stephen quote his tagline when he used to end the What's Up segments.
Yes, thanks, Don. So as John would say, look up in the night sky. It's the greatest free show
On Earth.
on Earth.